So today we're going to take a deeper look at slope. And our definition in our notes is that slope is the steepness of the line. It's the rate of change. We know it's m in the equation y equals mx plus b. And so the steeper the line, the faster that change is going to occur. And you can think of it as kind of skiing downhill. If you're skiing downhill, the steeper that slope is, the faster you're going to ski, or rolling a car down a hill or anything like that. So we also have our y-intercept where the graph crosses the y-axis, which is our b in the y equals mx plus b. And we have our x-intercept where the graph crosses the x-axis. And we haven't quite learned how to find that with our equation, but we can certainly find it on a graph. So if this is our y-axis, we can see that the y-intercept is where the line crosses that y-axis, so it would be positive 2. This is our x-axis, and we can see where the line crosses the x-axis is the x-intercept, which in this case is negative 2. To find the slope, it's rise over run. And so you want to take this dot, and you want to rise until you meet where the other dot will be. So we rose 2 and we ran 2. And you would write that as a fraction 2 over 2. And of course 2 divided by 2 is 1. So this line has a slope of 1. So let's take some more examples here. So slope, we know is our m in our equation. And it is rise over run. So make sure you're writing that in your notes. And it's actually written like a fraction. So rise is the numerator, and then run is the denominator. And you saw that in our songs if you listen to our songs. So here I have 2 lovely red dots on my perfectly straight graph. And to get from this one to this one, we have to rise 2. It's not always going to be 2, it just happens to be 2 here. So we're going to rise 2, and I'm going to put that on top as the numerator. Draw my fraction bar. And so from here, you're going to rise 2, and you're going to run 1, 2, 3. And so my slope for this line would be 2/3. Then we have the intercepts. You can see that the pink line crosses at y equals -3. I'm sorry, x equals -3. So my x-intercept equals 3. And my y-intercept is a little tougher. It's not exactly on the line, it's a little bit above. I'm going to call this a 2.2. And I made a mistake. Can anybody catch the mistake? So right here, this is not x equals 3. It's x equals -3. So Miss McKinney's going to correct your mistake just like I let you do. All right? So our x-intercept is -3, and our y-intercept is about positive 2.2. You can put that in a mixed number if that makes you more comfortable. But we're just giving an estimate of how that works. So then we get more complicated graphs. And you can see down here there's time. And over here there's distance. And these have specific meanings. So if you're 0 distance from home, you're at home. And so this person in 15 minutes kind of strolled down the street and went a little ways. And then they sped up because the steeper the line is, the faster they're going. Then they stayed in one place for about 8 minutes. And then they went back home because if you're 0 distance from home, you're at home. The maximum distance they were from home is 25 kilometers. And what we can do here is we can also figure out the slope. So it is rise over run. So we would rise 5 kilometers and run 15 minutes. So they went 5 kilometers in 15 minutes, 5 over 15. Well, you can reduce that to 1 over 3. So 1 kilometer per 3 minutes. So when we have changes in the lines and changes in slope, or when we have things at 0, they have a certain meaning. So what you're going to need to do on your worksheet is think very carefully about what the y-axis means and what the x-axis means in real life. And so this is time, and they're actually working in like European time, where you would subtract 12. So 17 minus 12 is 5. So this is at 5 p.m. And so they're probably, going through their own neighborhood a little slower, and then they're going a bit faster. They stay somewhere for a few minutes, and then they come back home. And so you want to think about the situations and what's really going on, because pretty soon we're going to be applying these to the Olympics, and we're going to be applying them to how fast somebody is going, or what they're doing, or if they're speeding up or slowing down. So take a look at that worksheet, do the best you can, and help each other out. On the back side of the worksheet, you're going to see some word problems, and you're going to be writing a formula in the form of y equals mx plus b. And when you're writing that formula, keep in mind that the slope is the rate of change, and it's something that repeats. If something repeats over and over again, like a monthly payment, or something that's over and over again, it's going to be your slope. The y-intercept a lot of times is where something's going to start, or it's your baseline. So take a look at that and write the equations in the form y equals mx plus b.